Let's study how to do input and output in the marie1 simulator. Here is a marie1 simulator launched. So we need to launch the editor, assembler code editor to do so. So let's write the code. First, command input is to read data from the keyboard and into the accumulator. And then output is to print the result on the display output, whatever is in the accumulator. And then let's halt the program there. Very simple one. So let me save it into there, named as input output.mas, and then assemble it. Now we are ready to load the assembled input and output, compile the code. Here's there. Now the input from the keyboard is read into this small window, input window. And then when you read it, you can choose what type of data you want to read from the keyboard. You could type in hexadecimal number or decimal number or ASCII code as is. So ASCII code, here is the ASCII code table there. So as you press uppercase A, that's corresponding to decimal number 65. So in input, if you choose ASCII and then if you press A from the keyboard, then 65 is entered, something like that. If you press lower A, 97, so if you press 0 key, 48 is entered. That. So you can choose how you want to enter from the keyboard. And then in output part, also you can display it as hexadecimal number or decimal number or corresponding ASCII code that you can choose. So let's run the program and then try that out. Run. The input command is there, so it turned into pink. It's now ready to read. So if I choose decimal and then 10 there, then I can press the enter key to continue. Then it goes output and halt. So at this moment, the output is an ASCII, so value 10 in ASCII is a line feed, so it's not a visible one. But if I change it to decimal, 10 is there. I can choose to hexadecimal, then 000A is 10, so that you can change those values. So let me try again. Run, restart, run. Now an input, I choose ASCII, and there as an input I press number 0 key and then press enter. Then number 0 is decimal 48, so if I change it to decimal, 48 is displayed. 48 in hexadecimal is a 30 is there, but if I choose ASCII, now letter 0 is displayed. So in any way, in the program, what is stored is a binary value, and the binary values are represented in hexadecimal code for a smaller number of digits there. So in this program, we have 3 lines at 0, 0, at address 0, input is 5000, output is 6000, halt is 7000. So those are 3 instructions. And then let's add another one. After the output, let's do store into data, and then let's define data as label, and default value, let me choose a decimal 0 there. And then if I assemble the code, and then if I do reload, now the revised code is there. So data is at address 4. So at address 4, currently it is 0 since I defined the value at that location 0. Now let's run the program. Run, and then choose input as a decimal. So if I give 15 decimal, then program halts, and then 15 is stored at address 4 at data, so 15 is F in hexadecimal. So at address 4, F is stored. Through the output, if I choose decimal, 15 is displayed. Hexadecimal, F is displayed. So you can see the internally inside the Maria simulator computer memory, they are all stored in binary. So we can verify that way. Here, one of the things I want to emphasize is that when you do restart, the Maria simulator restarts, but the memory is not cleared. Whatever was there, the memory contents are there, and then you can run again. So if I choose 16 now, the 1016 is stored. But if I do reset simulator, then simulator is a completely reset. Now you can load a fresh new copy of the program. So when you do the debugging, if the value remaining on the memory may affect your program execution for the logic progress purpose, then you'd better reset the entire program again.